Hello students, this is Miss Dalton and this is video 9.4, Horizontal Asymptotes of Rational Functions. So we just finished learning about vertical asymptotes, and so remember vertical asymptotes are determined by the denominator of a rational function after you have simplified the function. So if we look at this example right here, we've got our factors, none of the factors cancel, and so we set each of them equal to 0 in the denominator, and then we go ahead and solve that, and so we should have asymptotes at x equals 3 and x equals -6. So let's review real quick. Determine the vertical asymptotes of these functions. First, look and see if anything cancels. So in number 1, we don't have any factors that cancel. So we actually have to set all 3 of these equal to 0. So we would have x equals 0 as one of our vertical asymptotes. We would also have x equals 4. And we would have x equals -6. In the next one, we don't have any factors that cancel. So if we set the denominators equal to 0, we're going to get the vertical asymptotes x equals -4 and x equals 2.5. Okay, on the third one, notice that your x's cancel, and so you don't have to set that one equal to 0, but you would want to set the remaining denominators equal to 0. So you would have x equals -9 and x equals -6. All right, so let's talk some more about horizontal asymptotes. In order to find the horizontal asymptote, one way that you can do it is to focus on the degree of the numerator and the denominator. Now, what do I mean by the degree? The degree is the highest exponent after you've multiplied the factors together. Now, we're not going to have to multiply all of these together because really the degree comes from the very first term. Well, all that is going to be that first term is just the beginning part of each of these factors. So in this factor, I have x. In this factor, it's going to be x squared when I multiply them out, and this is x. So you need to take the exponents of all of these and add them up. So this has an exponent of 1, 1, 2, and 1. So the degree on this one is 2, 3, 4, 5. In the denominator is just going to be a degree of 3. So when you're trying to figure out horizontal asymptotes, you're comparing the degrees. And so let's go over how to do that. All right, so how you're going to use the degrees to determine the horizontal asymptote is this little acronym right here, Bobo Botan Eats DC. So let me tell you what each of those acronyms stand for. Bobo stands for bigger on bottom. Bigger on bottom, y equals 0 is your horizontal asymptote. And so here's an example. The numerator has a degree of 3 because we have x and then x squared. So that would be a degree of 3. In the denominator, we have x cubed and x squared. So that would be 3 plus 2, which is a degree of 5. You can see that the degree is bigger on the bottom, and so if it is bigger on the bottom, your horizontal asymptote is y equals 0. So Bobo stands for bigger on bottom, y equals 0. Okay, Botan. If it's bigger on the top, so here we have 1, 3, and 2. So 3 plus 2 is 5, plus 1 is 6. And then in the denominator, we have 1 and x squared, so that would be a degree of 3. You can see that it is bigger on top, so if it is bigger on top, then there is no horizontal asymptote. So you would just put none. Then the last part of the acronym is EATS DC, and so what that stands for is if the exponents are the same, then you divide the coefficients. So here we have an x squared and an x to the first power, so that's going to be a degree of 3. In the denominator, we have an x to the first power and then an x squared, so that's going to be a degree of 3 also. And so you take your leading coefficients and you divide them. So my leading coefficients are 6 and 3, so if I divide that, 6 divided by 3, divided by 3, you're going to see that you have a horizontal asymptote of y equals 2. Okay, so again, Bobo, Botten, EATS DC. So try and remember that acronym. It's going to help you determine what your horizontal asymptotes are. All right, so let's work through a couple of examples. So in this first one, again, count up your degree. So we have 2, 3, and 1. So that would be a degree of 6. In the denominator, we have 2 and 2. So that would be a degree of 4. So this one is bigger on top. So BOT, bigger on top, is Botten. So the horizontal asymptote would be none. Okay, let's look at the next one. So for this next one, our degree is 2 and 1, which is 3. And the degree of the denominator is 1 and 2, which is again 3. So this one is EATS DC. Exponents are the same. Divide your coefficients. So my coefficients are 5 and 4. So if I divide those, then my horizontal asymptote will be y equals 5 over 4. Okay, on this last one, I want to mention that you can simplify this first and then do the horizontal asymptotes. You should get the same answer. Because like on this last one, notice we can cancel an x plus 2 from one of the x plus 2's here. So then if we look at our degree on the top is just 2, and our degree in the denominator is 3 and 1, which is 4. And so still it is bigger on the bottom. So this one's going to be Bobo. So bigger on bottom means your horizontal asymptote is y equals 0. Sometimes you'll even see it like this. It'll say Bobyo, so B-O-B-Y-O, because bigger on bottom, y equals 0. Okay, so quick recap. To find the vertical asymptote, you want to use the denominator of the fraction after simplifying. Okay, and so you'll determine what values of x make the denominator equal to 0. So that's by setting each factor equal to 0 after simplifying. Then for the horizontal asymptote, you can either simplify or not simplify and use the acronym Bobo, Botten, EATS, DC to find the horizontal asymptote. All right, write down any questions that you have and I will see you in class.